Now in this video we'll see the configuration of Anycast with MSDP. Now before we get into the configuration, let's quickly revise how Anycast is going to work. Now we have seen this process in detail in the previous videos. Now I'm just giving some quick review on how it's going to work. Now the first step, we need to assign a duplicate IP address on both the routers which are supposed to be RP addresses. Now in my scenario, I'm going to configure an RP. The router 3 will be configured as an RP here and using the IPv4 address of 34, 34, 34, 34, and the same thing I'm going to do on the router 4 as well. Now I'm going to simulate some source sending some multicast traffic for a specific group. Now it's going to register to the nearest possible RP. In my scenario, the router 1, the nearest possible RP is router 3, and it's going to register itself with the S, G entries. And then I'm simulating a host or a receiver on the router 5, which is going to send some joint messages star, G here. Now all the routers point to any one of the nearest RP. That's the second step, as both are using the same IPv4 address. Now here in this scenario, the source will not be able to send the multicast streaming to the receiver, and the reason is this RP do not about the source, right? The router 1 do not know about the source, and the router 3 do not know about the receivers, because they are sending their own messages to the different RPs. Now we need to ensure that this information should be passed between two different RPs, and for that we are going to configure something called MSDP. So multicast source discovery protocol, and here we are doing intra AS multicast. Okay, so we are not doing it in between different AS, it's going to be intra AS. Now once we configure this, it's going to generate some MSDP source active messages providing the information of source to the next RP, and it allows the synchronization of the source and the receiver informations, and they both have the same synchronized group as G entries here, and based on that the receiver will figure out the shortest path to reach the source and get the multicast streaming here. Now this is the overall how it's going to work, the process we can say. Let's get into the command line and verify the same. Now for verification wise, I have already configured the routers with IGP and the PIMS pass mode here. Now if you go and check on the router 2, if I give show IP PIM neighbors, you'll find router 2 is forming the PIM neighbors with router 1 and router 3, and the same thing with router 4 as well. If I verify show IP PIM neighbors, the router 4 is forming the PIM neighbors with router 3 and router 5. Now IGP, these two things are pre-configured. Now the next thing is on the router 3 and router 4, I have just configured some addresses here. You can see I created a loopback interface, the first loopback interface, and the same loopback we are going to create on router 3 and router 4, which will be acting as an RP address, and we are advertising that into our OSPF, and then I'm going to configure a password on the VTWL line for testing purpose. Now the same commands we are going to copy paste the same thing on the router 4 as well, because on the router 4 also we are using the same address as an RP. We didn't configure the RP still, we are going to configure that. Now if you go and check on the router 1, if I try to telnet to 34.loopback, it's going to reach the nearest router. Now according to router 1, the 34. network is router 3, and the same thing if I try to do the same thing from the router 5, it's going to go to router 4. Now based on this telnet sessions, I'm just trying to confirm that this router, the nearest 34. network is router 3, and for the router 5 the nearest one is router 4. So which means if they need to go to RP, they will go to the nearest RPs. So according to router 1, router 3 is the nearest RP, and in case if that fails, then it's going to router 4. But right now both the RPs are available, so they are going to send their own messages to the nearest possible RPs. Now let's configure the RP on both the routers. So the configuration of the RP is, I'm going to use, it can be any configuration you can use, either static RP or auto RP, or you can use BSR candidate. So I'm going to say IPPIM RP candidate, and the RP address is loopback 34. Before I do that, I need to enable 34, IPPM sparse mode, and then after that I need to enable this command, and then I need to say BSR candidate. Okay, so let me check the commands. Let me copy paste the same commands on the router 4 as well, because I'm using the same loopback interface. Loopback interface number is same, also the RP here. Now if you verify on the router 1, let's try to generate some traffic. Now before I generate the traffic, let's configure on the router 1. I'm going to simulate a receiver. I got some configurations, let me remove them. Now these are based on my previous lab, SSM labs, so I'm not going to use source specific multicast here, so I'll remove all the configurations relating to that. So show run interface F0 by 0. Now the router 5 is joining to 224.5.5.5 is the multicast address. Now if I try to generate the traffic from the router 1, if I try to ping to 224.5.5.5, I should not see the reply. And if I try to repeat, I should not see the reply here. And the reason is, if you try to verify the same, if I give show IP route 224.5.5.5, now the router 1 says that 10.1.1.1 is okay. Its incoming interface is this, but there's no output interface list because there's no receivers, because it's sending some S, G entries to the RP, but the RP do not know anything about the receivers. Now similar way, if you check on the router 5, if I give show IP M to 224.5.5.5, now you can see star G entries, but the problem here is the router 5 is sending the star G entries to the router 4 RP, and the router 1 is sending S, G entries to the router 3 RP based on the nearest RP, because they both are using the same IPv4 address. Now we need to combine, so that's the reason you don't have reachability from this source to the receiver here, and we want to provide the reachability between them, so we need to configure something called MSDP between these two. So right now you will not see the communication here unless you configure MSDP, because they are registering with a different RPs. Now let's go to the configuration mode. Now what should be the configuration here based on the MSDP? I got the commands here. Now the first thing, we already did these things, so these things are already pre-configured here, so I don't need to configure this again. This is also pre-configured here. On the router 3 and router 4 we did the RP configurations. Now the configuration wise, it's a very simple. From the router 3 to 4 we need to configure MSDP, but when you are doing the configuration, ensure that we are using some unique IPv4 address to form the MSDP, and this address should be unique. You should not use the addresses what we used for RPs, remember that. So that should be unique on both the routers, and it should be advertised inside your IGP so that they should have a reachability here. So let's go to the command line. On the router 3 I'm going to use the loopback 0 interface. I think I have a loopback 0 pre-configured as per my topology. I'm going to advertise that. I'll just ensure that that interface is advertised. If not advertised, just ensure that you advertise that loopback interface. And then I'm going to say MSDP peer, and you can use question mark. The peer address is on the router 3. I'm going to pair with 14.0.0.1, that is the loopback on the router 4, and then we need to say connect source loopback 0. Now this connect source loopback 0 is more similar to your update source loopback 0 in the BGP. Now if you are peering with the connected interfaces, we don't need to define, we can simply press enter here. But when you, now if you do not define this connect source loopback 0 interface, in that case the peering will be established based on the connected interfaces. But here we are going to peer based on the loopback. So when you are peering, a loopback to loopback is recommended because the loopback interfaces are reliable interfaces, and we are saying connect source loopback 0. That's it. And there's one more command we need to say, originator ID. Now originator ID is more similar to your OSPF or BGP router ID, and by default if you do not define this command, it will automatically take the highest IP of the loopback. Now in my scenario, if I just try to check on the router 3, if I give show IP interface brief, it's going to take this address as a router ID, and that's something we need to ensure that it is not going to take these addresses as a router IDs. Now the main reason is it's going to identify each other based on this address, and we call it as MSDP originator router ID, and that address should not be the RP address. Now that's the reason to overcome that. What we are doing is we are simply saying that originator ID also should be the loopback 0 address. Now let's do the same thing on the router 4 as well. I'm going to advertise the 14.loopback interface in my area 0, and then I'm going to say IP MSDP peer, and the peer address is 13.001, that is the router 3 loopback, and I'm going to say connect source loopback 0, and then IP MSDP originator ID also loopback 0 address. Now after some time I should see the console message saying that MSDP peer is up, but right now it's going through some stages. After some time I should see that. Now once you see the MSDP peering is established, now the router 3 will send source active messages about the S-G entries to the router 4, another RP, and the router 4 is going to send back to router 5 the receiver. So you can see the message here, session peer is up, it's an MSDP peer, and if I verify show IP MSDP peer, I'm expecting the connection should be up, the state should be up, and I should see on the router 5, if I give show IP mroute, still I'm not able to see the entries. Let me generate the traffic from here. Now once I generate the traffic, I should see the replies from the router 1 to the receiver. That's what you can see there. And if you try to verify show IP mroute for 224.5.5.5, now I can see S-G entries as well as star-G entries. It has been pruned because of the shortest path. Now if you check on the router 5 now, the router 5 learns about the source from where the multicast traffic is coming. Now you can see there are S-G entries. These are the interfaces of router 1. Now you can see still, even though we are using different RPs, we can see that we have a source is going to register with the RP here with the star-G entries, and then the receiver is going to register themselves with it's S-G here, and here is star-G, and then based on the MSDP peer, it's going to send some source active message forwarding this S-G information to the next RP, and that RP is going to forward to the next hop routers. Now it's also going to provide us the redundancy option. Let's say if any one of the RP fails. Now if you try to verify the RP information on all the routers, if I give show IP PIM RP mapping, you can see the RP still remains the same for all the routers, but they are using different routers. Actually the IP address still remains the same, but they are using different routers as an RP. Like in this scenario, router 1 and 2 will be using this router 3 as an RP, and the router 5 is registering themselves within RP, but both are using the same address, but still they are exchanging the routes between them, exchanging the MSDP information, exchanging the S-G entries based on MSDP peering. Now let's try to shut down. So if I try to shut down any one of this loopback interface, if I try to shut down this, assuming that my router 3 goes down due to some reason, still the router 1 will be able to reach the multicast entries. Still they should be able to reach if I try to ping. Now there's no problem with the reachability, and if I try to telnet to 34.34.34.34 just to figure out the next what it is using, you can see I'm able to access the router 4 right now. Because if this nearest RP is down, they'll try to reach the nearest RP, which is going to provide us the redundancy, and if that comes back again, probably again they will synchronize. So let me make the interface back to up. Loopback 34, It has to be loopback 34, right? And then notion on command. I can see here, if I give show IP MSDP source active cache, you can see the information S comma G entries coming from the router here, from the router 3, that's the RP address here. Now in this way we can provide end-to-end reachability from one PIM domain to another PIM domain by using MSDP peering with the two different RPs, providing the redundancy as well. It's going to provide us the high availability as well.